Hi there, Mr. Sutton bringing you the first lesson in a series on exponential and logarithmic functions. To start off, we're going to review the exponent rules that you may have seen before, and we're going to simplify expressions using those laws of exponents. For your first warm-up, pause the video and see if you can simplify this expression using only positive exponents. Alright, let's see what we came up with. First thing we have to do, just following basic PEMDAS, exponents come before multiplying and anything else really. So we have to raise everything inside here to the second power. In fact, that's what you do when you have an exponent outside of parentheses with multiplication or division. You have to raise everything in there to the power outside. So we'll have negative 4 to the second power and x to the third to the second power. Now, negative 4 squared, we probably know what that is already. That's 16. But when you have a power raised to a power, remember you have to multiply the powers. So this will be 16x to the 3 times 2, or x to the 6th. Next thing we have to do is multiply these two terms together. Now, when you're multiplying the exponent, the bases here, you're going to have to add the exponents. So this is going to be 48. So we're multiplying bases, adding exponents. We're going to have 48 x to the 6 plus negative 9, which is x to the negative third power. And they did say simplify using positive exponents. So remember, negative exponents mean reciprocal. So this x to the negative 3 is really 1 over x to the positive 3. Now be careful, because only the x is moving downstairs, because only the x has the negative exponent. The 48 has no negative exponent, so it stays right where it is. Hopefully that first warm-up went all right for you. Try this second one now. So a few things we have to do with this fraction. We know we can always reduce constants in fractions, so 30 over 12, both divisible by 6, so we can make that 5 over 2. But what about all these exponents? So rule to remember, when you're dividing bases, the same base, you have to subtract the exponents. So we'll have a 5 on the top, 2 on the bottom, and we'll have x to the 9 minus 9, which is x to the 0, y to the 5 minus 14, which is y to the negative 9, and z to the 8 minus, invisible 1, sneaky, so that's z to the 7th. Negative exponents, we know where that has to go. This is the reciprocal of y to the 9th, so we have to have a y to the 9th coming downstairs. But what about this x to the 0? So another one that's useful to remember, whenever you have a base to the 0 power, that always equals 1 no matter what. So this x to the 0 is really just 1. 1 times whatever is just going to go away, right? So this is really just going to be a 5 and a z to the 7th staying on top. And then the 2 stays down here along with y to the 9th. We're going to do a few more problems now where we do a little bit more with those exponent rules. Pause the video and try this one out. So we're going to have to distribute this term outside. So going term by term, remember you're going to be adding the exponents when you multiply like bases together. So this is going to be 8x to the 0. And then times the second term, we've got 56x to the negative 4. Simplifying now, x to the 0 is 1. Now be careful here. Only x is getting the 0 power. So you really just have 8 times 1. And then this will be 56 over x to the 4th. Let's take a moment to review another important topic, fractional exponents. Now you might remember that when you have a fractional exponent, you can rewrite that with the numerator as a power and the denominator as a root. So for example, if you have x to the p over r, you can write that as x to the p power and the rth root of that, or the rth root of x, all of that to the p power. It actually doesn't matter what order you do the root and the power in. You can actually pick which one you do first. So when you're trying to evaluate a constant to a fractional exponent, it's usually a good idea to put it back in radical form. So 216 to the 2/3 power, 3 is the root, 2 is the power. So you could think of this as the cube root of 216 raised to the second power. And again, you get to choose which of these things you do first, but honestly, I think it's probably easier to take the root first and then do the power. Otherwise, you're trying to take the cube root of a very large number. So what is the cube root of 216? What do I have to cube to get 216? Hopefully you remember that that is 6. So we're doing 6 to the second power, which is 36. All right, pause the video and see if you can tackle this next one on your own. You'd have to do a little simplifying first. So remember, when you have an exponent to an exponent, you're multiplying the exponents. So this is really 25 to the negative 1/3 times positive 3 over 2. Now, fraction multiplication, you're just multiplying straight across. But a little shortcut here, you might notice we have these two 3's. Those can cross-cancel, and this is just 25 to the negative 1/2. Now, as far as fractional exponents go, this is a really friendly one. Yeah, we do have to take care of this negative. So this is going to be 1 over 25 to the positive 1/2. The 1/2 power, this 2 is the root. So that's really square root of 25 to the first power, which we don't really care about. So it's just the square root of 25, and the negative means we have to move it into the denominator. What's the square root of 25? Oh, 5. So this is just 1/5. Here's another problem that looks nastier than it is if you just take it step by step. So pause the video, get as far as you can, and then we'll pick up the pieces after. First step I would do on this one, and you do have options, but I would distribute on the top just to get only two things up here. So we've got 5 times negative 6 is negative 30, and we've got n to the 2/5 times n to the 2/5. Now, again, you're adding the exponents, and we need a common denominator since those are fractions. Fortunately, these all have a denominator of 5. So this is just going to be 4/5 for the power up there. And then we've got 5n to the 2/5 times negative 4n to the 7/5. So that's going to be negative 20 n to the, let's see, 2 plus 7, that's going to be 9/5. Let's go ahead now, and we're going to distribute some division. Whenever you're dividing two terms by just one thing, you can divide both of them by that denominator. So we're going to have negative 15, and now we're subtracting the exponents. So this is n to the 4/5 plus 1/5, same thing as minus 1/5, negative 1/5. So that's going to be the 5/5. And then we'll have negative 10, n to the 9/5 minus negative 1/5, or plus 1/5. So that's going to be 10/5. A little bit further now that we can go. 5/5, that's just 1. So this is just negative 15n. And over here we'll have minus 10n to the second power. We're going to do one more problem that ties in a few different concepts. Pause the video and see if you can figure out how to simplify this expression. All right, so for our first step, we need to turn these into fractional exponents. We don't really know how to multiply different radicals, so let's just put this in exponent form. We've got x to the 2 over 9. Remember, power over root. Roots go on the bottom of trees and fractional exponents. And then we have x to the 7 over 6. So now we have to add these together. Before we add these, though, this is a little bit trickier. We need an LCD, and we don't have the same denominator. So our least common denominator, we're going to have to figure that out. What's the smallest number that 9 and 6 go into? Oh, 18. And if you forget how to do that, you can just take the bigger one and take multiples of 9 until you find something 6 goes into. So that is 18. So we have now x to the, rewrite this with an 18 on the bottom, so that'll be 4/18. And this will be x to the 18 on the bottom, so we need 21/18. So we'll be adding 4/18 and 21/18 together, and that's going to be 25/18. This concludes our whirlwind tour of exponents. Until next time, this is Mr. Sutton, signing off.